Hi everyone, in this lesson we're going to be working backwards. This time we've been given a graph with some markings and values and we have to go back and determine the trig function. We've been told that we're to look for a sine function here and we have b multiplied by x plus c in brackets. So the first thing I'm going to do is figure out where the equilibrium point is for this graph. I note here that the top of this crest looks like it's in line with positive 1 and the depth of the trough here looks like it's in line with minus 3. Halfway between those 2 points would be here at negative 1. This will be my equilibrium line. I get then that the amplitude is 2 because I've moved from there upwards by 2 or I've moved downwards by 2 and I have an equilibrium at negative 1. So that's straight away a couple of good things to know. Amplitude is 2, A, and D equals negative 1. The next thing I want to do is try and figure out the period of this thing, how long it takes to cycle. So I note here that that's 2 pi, and if I run straight downwards from 2 pi to that point, that seems to me, just by eyeballing, that that's exactly equivalent of that point there. So that's very handy because that's it's not the bottom, the minimum is a bit to the left, but that is just a bit past minimum. We go up to maximum, we go all the way down to minimum, and then we're a little bit past minimum. We're at the equivalent point in the cycle. So that represents the period. The period is 2 pi. That's pretty convenient. Now remember what we knew. We knew that b equals 2 pi divided by the period. So 2 pi divided by 1 in our case. Well, what did I say? 2 pi divided by the period of 2 pi. That means b equals 1 for us. That's very handy. Now we've got almost everything we need. We know that the equation is y equals a by the sine of bx plus c plus d. We have the horizontal shift. Sorry, no, we don't. That's the one we don't have. We don't have the horizontal shift. What was I saying? Let's take a look, though, and see what we think we can find for horizontal shift. Now, this is where we take a little bit, we have to make a bit of a judgment here. If I look at where the minimum point is there, I think, and it all relies on estimation, I think that that minimum point is in line with 11 pi over 6. Now, the minimum of a graph for sine, it would usually be back over here somewhere, wouldn't it? So we have to try and work out how far that has moved compared to normal and whether it's moved right or whether it's moved left. Sometimes that's a bit confusing. There's an alternative, slightly easier way to do it. Although, well, let's keep going. Let's keep going. Where would my base function be if I just went y equaled 2 sine of b is 1 times x. I'm going to leave the c out for a minute, minus 1. So where would that function be? Well, it would have the same equilibrium, it would have the same period, and it would have amplitude of 2. Now we know that our function, our base function for sine would begin here. And after going pi over 2, it would be here. After going pi, it would be here. After going 3 pi over 2, it would be here. Here, which is the minimum. I stopped on that line. And then after going 2 pi, it would be back to here. That would be the base function. So I'll sketch that in just to help visualize what's going on. Now this, when I say base function, I mean it's everything except the horizontal shift. Where is our point here? Well, how far has that minimum seemed to move across? It seems to have moved across by that far. That far is, each of these steps is pi over 6. So it's 2 pi over 6 or pi over 3. And it's to the right. If I wanted to shift this function to the right, I would have to go subtract, and the amount is pi over 3, and I still have that -1 shift. That is going to be my formula. I'll do this on the graphing calculator to see if that agrees with us. Let's go. That's my base. Let's go back and modify this. Let's do this step by step. Let's go subtract 1. And that certainly did move my equilibrium position down to -1. Let's go and put a 2 here at the front. And that certainly increased my amplitude as I wanted, so I'm now up to a maximum +1, down to a minimum, and that's more or less what I've sketched there with the red dotted lines. The only thing is, I need to shift the thing to the right. Fortunately, b equaled 1 in this case, so all I need to do, now shifting to the right means subtract, and I think just by lining up things on the grid, I think it was pi over 3. There it is. Does it seem to be that the at x equals 0, our y-intercept is close to -3? Yes, it does. Does it seem to be intersecting here, the x-axis, close to pi over 2? It sure does. These steps are pi over 6, just the same as the picture. So that's pretty close to pi over 2. And does our minimum here on the actual graph seem to be just at 11 pi over 6? Well, I think it does. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 11 pi over 6. That's our minimum. So we got it. There is how we do this. We pretty much use the same process as we did the other time, but we work backwards. We work backwards from where the graph is. And if you find first D, then A, they're usually the easiest, then find B, lastly worry about the phase shift C. And that's the way it goes. Thanks for watching.